By continuing our topic that is waves, today we will take and talk about the displacement relation in a progressive waves. So under the topic waves, there is a subtopic displacement relation in a progressive wave. Displacement relation in a progressive wave. In order to describe the progression of a wave in a medium can be anything, it can be air, it can be liquid, and the motion of any constituent of the medium, we need a function that completely gives the shape of the wave at every instant of time. Let us suppose t. Now for example, to completely describe the wave on a string and the motion of any element along its length, we need a relation which describes the displacement of an element at a particular position as a function of time, and also describes the state of vibration of various elements of the string along its length at a given instant of time. Now, for a sinusoidal wave, we have a figure in 15.3. What we see there is a function should be periodic in space as well as in time. Let us suppose we have function y xt. This denotes the transverse displacement of the element at position x at time t. Which further denotes the transverse displacement of the element at position x at time t. As the wave sweeps through succeeding elements of the string, the elements oscillate parallel to the y-axis at any time t. Now, at any time t, the displacement y of the element located at position x is given by a sin kx minus omega t plus phi. So here is the equation of our function. Let us suppose this is equation 1. Now one can as well as choose a cosine function or a linear combination of sine and cosine functions, such as here we can write in terms of sine and cosine function. The equation first, in terms of sine and cosine function, the equation 1 becomes a sin b cos kx minus omega t. Now in this equation we have amplitude A and we have phi. So we can write, let us suppose this is equation 2. In equation 1, A is under root of a square plus b square, and angle phi equals to tan inverse b upon a. Now the function represented in equation 1 is the periodic function in position coordinate x and time t. It represents a transverse wave moving along the x-axis. At any time t, it gives the displacement of the elements of the string as a function of their position. Now, it can tell us the shape of the wave at any given time and shows how the wave progresses. So, function as that equation in equation first represents a progressive wave traveling along the positive direction of the x-axis. So we can write over here that what this equation 1 presents, we already discussed. And what about the equation 2 presents? We can write in the function a sin kx plus omega t plus phi represents a wave traveling in the negative direction. The set of four parameters here, the set of four parameters likewise a, I, k and omega completely describe a harmonic wave. The names of these parameters are displayed in figure by 15.5 also, which we already discussed. Okay, so a function can be described as y xt. This will be a displacement. A will be the amplitude. Sine is our function. Here kx minus omega t plus phi. Now this will be a displacement. In this equation, this is a displacement. In this will be a displacement. So we can write over here like this. A will be a amplitude and this whole term is phase. Now independently kx is known as angular wave number, angular wave number. Omega t is known as angular frequency, angular frequency, and phi is known as initial phase angle, initial phase angle. So in figure 1, these are the names of quantities, the names of the quantities for a progressive wave. Now in order to understand the definition of the quantities in the above equation, we have to consider the graphs that will be shown below figure. These graphs represents basically for these graph plots differently for the 5 different values of time t as the wave travels in positive direction of x-axis. So let us discuss about the graphs first of all. Here is our first graph. We need to carefully see about that the designs of the graph will be same as they are. This is our graph A. In this graph, the progression of wave towards the x-axis that will be shown by arrow. This is y-axis. So this will be our amplitude A we talk about. Now a lambda will be a complete wavelength that will be denoted by like this. A complete wave, the length of a complete wave is known as wavelength. So here we can just denote wavelength as lambda. So this is our wavelength. Now talk about the figure graph B. Here in this graph we have something like this. This is again showing a progression of wave in x direction. and this will be a y-axis, this will be a figure B. Here in figure C, the direction of wave progression again along the x-axis, and we can show this like this, that in starting our arrow will be here. Now in figure B, this arrow will be produced by here. Now here, this arrow will be here. So what we can see here, progression of a wave. This is diagram C. This is x-axis, this is y-axis. Here you can see that arrow is moved bit ahead. This is figure D. This is figure E. Now, by the above 4 or 5 graphs, we can clearly see that our arrow is moving towards the x-axis or along the x-axis. This will also represent that our wave is propagating along or towards the x-axis. So under figure 2, we can write that plots of equation 1 for a wave traveling positive direction of an axis, positive direction of an axis with 5 different values of time t. A point of a maximum positive displacement in a wave, point or we can say a point of maximum, a point of maximum positive displacement in a wave shown by the arrow in above plots or graphs called crest. You can underline this. And the point of maximum negative displacement is called trough. The progress of the wave is indicated by the progress of the short arrow pointing to a crest of the wave towards the right. Now, as we move from one plot to another, the short arrow moves to the right direction, or small arrow moves towards the right direction with the wave shape. But the string moves only parallel to y-axis. It can be seen that as we go from plot A to E, a particular element of the string has undergone one complete cycle of changes or completed one full oscillation. During this course of time, the short arrowhead or the wave has moved by a characteristic distance along the x-axis. And one more important thing is the wavelength. Wavelength is a word which is constitution of wave plus length. That means the complete length of the length of a one complete wave is known as wavelength. Next topic, we will discuss about the amplitude and the wavelength of phases, the wavelength of the angular wave numbers, and more about the periods, angular frequency, and the frequencies.